Hi everyone, this video is to talk about the difference between solving and simplifying, or factoring and solving. We have different directions that keep coming up in the homework, and it's easy to get confused on which directions mean what and what we're supposed to do when we see each problem. So we're going to go through some examples of sort of each set of directions and how to interpret them. So we're going to look at the difference between expressions and equations. We work with both of these in our class, and we need to be able to tell when we're supposed to simplify and when we're supposed to solve. Okay, so the short answer to that, oops, too many slides. There we go. The short answer to that question is we solve equations. And you may be wondering, well, how do I know if it's an equation or not? And the answer to that is that it has one of these symbols. If it has an equation sign, then it is an equation. Anything else is an expression, and the only thing that we can actually solve is an equation. If we see an expression, then we're either factoring or we're simplifying, but we're not solving. So let's look at an example where we're factoring. Here we're told by the instructions to factor this x squared minus 9, and that would be the difference of squares, because it's x squared and 3 squared. Since they're asking us to factor, we're going to break apart what they're given. So they gave us something that's already been, for lack of a better term, it's already been mushed together, and it's our job to break it back apart. So imagine that the binomial you're looking at, x squared minus 9, is an egg, and it's our job to crack the egg open and get 2 halves. So we have x minus 3, x plus 3, and we got that by using the difference of squares. You can factor it the regular way using trinomial with a 0 as a middle term, but it's faster and easier if we memorize the difference of squares and apply that. So here we're going to look at instructions to solve. And the main difference here would be that, 1, the instructions say solve, and 2, there's an equation sign. So the equation sign tells me that at the end of this, I should have an x equals something. So in other words, I should be isolating the variable, getting it all by itself. We can see that we still have our x squared minus 9, and the first step in solving would be to factor that out so that we can use our 0 factor rule. So we factor it into our difference of squares again, and then we set each factor equal to 0 and solve. So here we would add 3 or subtract 3 to either side, and either way we would get a negative 3 and a positive 3. In this example, the instructions are asking us to simplify. They're giving us 9 over 9 plus x plus 3 over x. And since they're asking us to simplify two fractions, we're going to need our LCD. Note that each denominator is already factored and they have nothing in common except x, but since it's not the only term in one of these, then they're going to count as separate factors. So our LCD will be x times x plus 9. So our first term is missing an x, so we'll multiply by x over x, and our second term is missing the 9 plus x over 9 plus x. That gives us a 9x plus 3 times 9 plus x, and we'll just write it over the top of the single denominator that we have. The next step in simplifying would be to distribute our 3, and then combine all of our like terms and double check to see that it doesn't factor any further. So on this slide we're going to distribute our 3, we get 18 plus 3x, and that gives us 12x plus 18 over x plus x times x plus 9. We can factor a 6 out of the numerator, and that gives us a 2x plus 3, but there's no way to turn that numerator into 9 plus x, so this is as simplified as this particular expression can get. Here's our last example, and this is a solve with rational terms. So since it's telling us to solve and we have an equation sign, we're going to solve, and to do that we're going to clear fractions because it's too hard to work with those variables down in the denominator. So we have two denominators, r and r squared. Since the highest exponent on either denominator is the square, our LCD is r squared. So we're going to multiply both sides of the equation by r squared. That means we have to distribute the r squared to each one of these terms. And I can see when I distribute it to the first term, it's got an r to the first, so I'll be left with an r in the numerator. When I distribute it to the second term, it's got an r to the second, so both r's will cancel, and I'll just have a 3. On the other side of the equation, there's no denominator, so I'll have 4r squared. I need to move the 4r squared over because I want to be able to factor this to be able to use a zero factor rule and solve for r. So that gives me a negative 4r squared on the left-hand side, plus 4r plus 3 is equal to 0. I can't work with that negative, so what I'm going to do is multiply both sides by -1, which essentially just changes all the signs. Then I can use my superstar method to factor. So I need numbers that will multiply to give me -12, that add to give me -4. I've put my 4 as my leading coefficient in the top of these little fraction bars, and I'll try and find two numbers that work and then reduce those fractions. So I can see -6 and 2 will work, and I can reduce them to 2 over 3 and 2 over 1. So this factors into 2r minus 3 and 2r plus 1. The signs are coming from the signs in the superstar, so I have a positive 2 over a -3 and a positive 2 over a positive 1. Set that equal to 0 and use the zero factor rule to separate them into two equations. In the first, I need to add 3 and divide by 2. In the second, I need to subtract 1 and divide by 2. So I'll end up with r is equal to 3 over 2, or r is equal to -1 over 2. So to summarize, we can factor, we can simplify, or we can solve. When we factor, we take things apart. When we simplify, we put things together. And when we solve, we find the variable. So we make the variable all by itself. We isolate the variable. And we would look like x equals 2. Let me rewrite this, solve. So when we solve, we isolate the variable. We would get like x equals 2 or r equals 3 or some sort of variable equals a single number at the end. Okay, I hope that helps us kind of tell what we're doing in each one of these problems. Factor we take apart, simplify we put together, and solve we're trying to get a variable equal to something.